Hey, hello, and welcome to the show. It is me, John Park. What is going on here? I didn't mean to show you all that just yet. I was just, hey, what up? This is the Product Pick of the Week show. It's me, it's Tuesday. Here we are all together. Thank you so much for stopping by. Thanks for popping in over into our various video feeds for the live stream. One thing you may notice if you're somewhere that isn't YouTube is where's the chat? Well, the chat is over in our Discord, so go check that out. Head over to adafruit.it/discord. That's adafruit.it/discord. You'll get an instant invite, and you can head over to that right there, the live broadcast chat channel, to go hang out. Thanks for popping by, Thin Man and Squid.jpg and Paul Cutler and anyone else who comes along. We also have our chat over in the YouTube, so thanks for popping by over there to Dave Odessa and Beatagraf Avdelhagen and Robert Cochran. Hello. So, what we've got going on today, hi Johnny Bergdahl, also popped by. What we've got going on today, I have a product pick for you. It is right over there, so if you want to go check that out, head over to that URL right there. It's product 6318, or you can use that QR code. You can also use the shortener, adafruit.it/6318. That'll take you there. Oh no, I have an echo, someone said. That is weird, because I have a mic, a second mic I'll be using today. But why is that picking up? Let me see, let's try to settle this. I don't want you to have to deal with an echo. Oh, no. Does that get rid of it? Perhaps. Oh, there isn't an echo, someone said. Huh. Well, thanks, Liz. You can just say words, like DK can just say echo, and I'll lose my mind. But either way, head over there, echo or not, and you will find the product page. This very show is broadcast from inside of that product page. And there is, let me double check, a big discount on this week's product pick. It is 50% off. We have stashed 100 of them, thanks to the product team, thanks to Jelly and Travis and anyone else helping out with that. A minimum of 100 are stashed before the show. Now they're available. Maximum of 10 per customer. So 10 of you got real excited, they'd be gone. But either way, you'd get them at half price. So go check that out. But before I say any more, let's have Lady Ada come on and talk about this one. Take it away, Lady Ada.
Yeah, this is a I2C to 8-channel solenoid driver. This is a common request that we've seen is people are like, I have to wire up a lot of solenoids, and I'm like, or like unidirectional motors, and I'm like, yeah, you just like there's no really easy way to do it. You have to like have all these transistors and flybacks and stuff. And I've noticed that people either have like one solenoid or 20 solenoids. Like no project really has like 3. It's often like, or 2. It's often like 8. So if you're making like your metallophone or your robot, or you're doing something with model trains, whatever, you have a lot of solenoids that you're trying to control. Maybe you work at the House in the Rock in Wisconsin, and you have to update all of these old solenoid-driven robotics. This would be a great board for you. So it uses I2C to a GPIO expander, the MCP 23017. That will give you 16 GPIO. What I like about it is it's push-pull, so it's really great for driving the transistors. So on the board itself, actually here, on the board itself, we've got 8 3-amp transistors. Each one has a flyback diode, and it has a little red LED to let you know when it's activated. They're by default off, so when you power it up, you're not going to like get any jitter or anything. And then over I2C, we've got code. The MCP 23017 is a very, very popular expander chip. So there's code in Python, Rust, Arduino, CircuitPython, MicroPython, whatever. Use port A as the solenoids, and then we also expose port B. So if you want to have 8 buttons or 8 LEDs or whatever, we also expose those. And then there's 3 address jumpers. So if you want to use it solderless, you can just actually plug and play, get it going immediately with no soldering. But if you solder closed those 3 jumpers, you can connect 8 of these for 64 total solenoids. at once.
If you want to cosplay as Luke's chopped off hand from Empire Strikes Back, this is for you.
Definitely,
I'm stealing that joke from the chat.
Okay.
Yeah, it's funny.
Okay.
All right, indeed. I have to use funny camera work here for this one today just because I have everything all wired up in both cases. But that, get it into focus right there. That's the product pick of the week this week. It is the I2C to 8 channel solenoid driver. This can be used with Stemma QT, so you've got easy hookup. It can be solderless because we can provide power to these little middle screw terminals, and then all of the solenoids that you can drive, all 8 of them, have their own screw terminals that they can be connected to. As Lady Ada mentioned, there's a second channel of the expander chip or set of these 8 channels that can be used for buttons. So you can see here B0 through 7, and their accompanying grounds can be used there if you want to use inputs on them. But it's all run over I2C, so the connection to my Featherboard in this case is over I2C. And this can be used for all kinds of servos. So I've actually got in both demos that I'm going to show you, I've got little servos, but you can drive these nice door lock servos, which I think are 24 volt. This will drive anywhere from 2 to 24 volt servos, which is pretty great. And you just give it the power that you want. All of the servos are going to use the same power, but you give it the power you want over that middle set right there. And what else can I say about it? Let me show you a couple close-up pictures here while I talk about it. So it is the MCP 23017 expander. Each of the channels of the 8 solenoid channels that you can drive have a AO3406 N-channel MOSFET and flyback diodes to protect any back current, so the thing will run without disrupting your board. Board logic can be anywhere from 3 to 5 volt logic, and this will work with Arduino, it'll work with CircuitPython, pretty much work with any board that has I2C on it. Particularly convenient if you have I2C with a Stemma QT /quick port, so you can just plug, off you go. And as Lady Ada said, there are address jumpers on the bottom, and you can use up to 8 of these boards by selecting different I2C addresses so that you can drive up to 64 solenoids. You just got to give them nice big power supplies of the right voltage for the solenoids that you're driving. As Beatograph Abdelhagen said over in YouTube, vaguely thinking pinball table. Yet another thing too large for my apartment. Yeah, fantastic. If you want to make your own little pinball table, you need to drive a lot of solenoids. I love it. Great idea. If you are Liz Clark, our very own Blitz CD DIY, then you're going to make musical instruments like xylophones or metallophones or different kinds of drum machines. Reuse Brothers have made some solenoid drummer projects before. You can play all kinds of instruments by striking them using solenoids. And I want to take a look at the, I'll go back to the bottom of the product page here. If you scroll down, you can see we got this video playing in here. If you have that one clicked and another one clicked, you might be getting that echo we were trying to discern, so watch out for that. Primary guide right here, as well as a couple of project guides. So if we take a look, primary guide there, you can see this one in this case is actually driving 5 volt solenoids using 5 volt on this Metro. You're not going to get a ton of current. You probably can't drive too many of them at once. But in sequence like you see there in that little animation, that'll work great. You can take a look on the pinout page. This will let you know everything you need to know about I2C pins, the pins that are broken out on it for using solenoids, using buttons. This is port B interrupt pin, and on and on. And this will also give you an idea using this handy guide which combinations of soldering up the different address jumpers will give you different addresses, so you can get up to 8 of these going. And then we have pages for setting up in CircuitPython with examples, Arduino with examples, and downloads. If we take a look at some of the projects here, there's this solderless robot toy xylophone that Liz created that uses MIDI to strike this little tiny xylophone, which is very cool. This Not a Typewriter project, I actually made a minimalist version of this. I love this project. I made a little mini version of this that I can demo for you, but the one that the Ruiz brothers and Liz setup here uses a couple solenoids to click every time you type on your keyboard, and every, I think, 30th or so strike, it'll ring the bell like you're hitting a carriage return, which is pretty cool. And let's get to the demos, in fact. So I'm going to switch to, go back to this view here, and I'll fix my focus. You can see I'm zoomed fairly far out here so that we can see my extra keyboard here. So this is actually plugged in via this feather to my computer, so this will control my computer. So I'm just going to be careful about where I click so that I'm not typing any key commands or things that'll interrupt the broadcast. But if you see here what I've got going on, there's a USB cable running to the computer, the feather with USB host RP2040, then my keyboard is plugged into that. Oh, you can see a little preview there. And then the data is going and power is going to the solenoid driver board from this feather. So again, I'm only driving a single 5-volt solenoid in this case. I simplified it so I can run the power directly off of the feather without a problem. I'm actually using 5 volts off of the USB line, so it's coming from the computer as well. And then plugged into just one of the 8 channels, I have this little baby solenoid here that I've adhered to some Lego. So you can see there, let me click somewhere else. As I type on this funny little LED backlit keyboard, with every stroke that I type, we get the little solenoid driving. Just so you can see what is going on here when I type, I'll just go up to a little commented out section. There you can see, even tick, 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 tick. Probably need our whiteout, but tick, 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 tick. Oh, did I break it? I think I just broke something. Yeah. let me see what did I do. What did I do to you? Let me restart it. Oh, I've got something stuck. Oh, there we go. Oh, some key is wow. Some key is wow. All right, let me unplug some things. Let's try replugging that keyboard. Okay, there you can see, this is running all in CircuitPython. So down here at the bottom of the REPL, it says USB typewriter started. Bell will ring every 25 keystrokes or when enter is pressed. I excluded the bell from this because I couldn't find one. And what's going on in the code here is we're importing the MCP230XX and then 23017 variant of that chip as our GPIO expander. We're also using USB host stuff to be able to host a full keyboard. And then setting up some intervals here for the timing. When a key code that is recognized is pressed, one of the keys here, in this case the key strike solenoid is set up on pin 0, bell solenoid on pin 1. I think I have those. Why do I feel like those are reversed? And these are set to outputs, so those pins are set to outputs, which will then use the MOSFET to drive that, send that full 5 volts through. And then when a key is pressed, the solenoid value equals true is all it takes to send current to that solenoid, energize it, and drive the little slug. When we release, we can actually drive it in reverse or just release and the spring will set it back. So those are kind of the basics of solenoid driving. Let me open up. See if I have this example. I'm just going to open this one called For Solenoid Test. And I'm just going to set it to a single solenoid here. I'll just go and change this list here. So I'm setting them up, but let's see, solenoid. I feel like this is plugged into, yeah, let's do solenoid 2. So here, same thing, setting it as a MCP pin, switching that output, setting the value false. And then here we're just going to every, let's say, second, energize that and release. Click, click, click. You can see right there. On the driver board, there's a little LED that lights up when that's energized, which is nice, so you can kind of see it in action. And then we can adjust the timings here so we can make this happen much more quickly. Tick, 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 tick. Now, this gets the rhythm going here and makes you want to create a little drum machine sort of situation. So let me move this stuff out of the way and show you a second little demo I put together. And the main reason I actually did this is I wanted to actually hook up 8 solenoids to one of these. I have a second one over here. And see how it worked. So let me go back to a full view here, and I'll show you what I've got here before I turn it all on, because it's a bit of a complicated situation. So I have a wood box here. Inside it is pretty much everything, and you can see I have a contact microphone. That's a little piezo contact microphone that I've adhered to the top there with some tape and some blue tack. And running into it is a Cutie Pie. So there's a Cutie Pie via stemma. I'm trying to fix this camera. Cutie Pie via stemma that's running the solenoid driver board that's inside. So that's got its own USB 5 volts to drive the Cutie Pie. So I'll set that up in a second. Also running into there is 5 volts that I just happen to be going into the through a USB-C to DC converter just to make the wiring easy for what I had on hand. And if we open this up and take a look, it's all kind of upside down. Let me yeah, I'll leave it upside down, but I'll explain what this is. So we have solenoid driver board right here. You can see I have 4 solenoids here on channels 0, 1, 2, and 3. And then the others are sort of scattered around a little bit. Some of them are touching the wall. Some of them are built on Legos that can hit the wall. Some of them are moving around freely. And then I have another contact microphone here at the bottom so that we can get some nice vibration from this. These are running out to, I'm not going to show this stuff off to the side, but I have a contact mic amplifier as well as a little bit of sort of a reverb effect going. So let's see what happens here if I give power to solenoid. And you probably can't hear that too well, I'm guessing. It's because all I have right now is this little lav mic. But what I'm going to do is bring up a second channel, and I'm just going to preview that. Okay, that's pretty cool. And then just to see, let me know how that sounds. That level down is a little much, sorry. Probably a little better. Let me know how that audio level is, and then I'm going to go ahead and plug the Cutie Pie into my computer so that we can look at the code and adjust that code. So I'm going to unplug this for a moment. All that clacking. I was just running that from a battery. But now I'm going to run that Cutie Pie into my computer so we can take a look at the code and adjust the timings on that. So let's plug this back in. As you can see here, oh, I've blown apart one of the, I've blown apart a Lego mount there, but that one's jumping up pretty aggressively. See them all doing their thing. Clickety clack. And let's see let me see which contact mic I have. Let me use the one that's inside of there. 1 second. they used to own. Yeah, what is it? Okay, and so now what I'm going to do is open that code, because that's now the QT plugged in. And I'll go to this code view. Go into the REPL here so we can stop the thing for a second. There we go. Phew. Okay, so how this works, very similar to that simple example I showed there. I've got 8 solenoids now. I'm calling them solenoid 1 through 8. Those are on pins 0 through 7. I've imported the MCP 23017 and set it up on I2C using Stemma QT cable there. All of these are set initially out to outputs, but values set to false. Creating the list of the 8 solenoids, and then this is the only loop right here. I'm just triggering those with this timing here. So let's start that up again. Move that out of the way. Oh, bad news. One of them was trapped and I overheated it. That's why it's doing a little restart. Let me figure out which one that one was and take it out of the... It's number 8. All right, so let's go to 7 of these. Let's resave. I think it's just this one. There we go. All right, we pulled one out of the loop. That one was trapped in there just because of my hasty assembly there. That one is toasted. So now you can see, if we go over to the timing in here, I've got this very brief 0.5 second actuation of it, and then I give it a rest for 1/10 of a second. Let's double that. We'll slow the whole thing down. Now you can see them a little bit better. I'm not sure if this camera will hold. Yeah, there we go. There we go. Go half speed from that. There you go. You get kind of a nice little marching sound, I think. There we go. Leave that alone. So you can strike interesting things, which I'm not in this case. I'm actually just picking up with the piezo. They have some slightly different sounds to them based on if they're hitting the wall or if they're on Lego. And then I'm taking that and sort of processing that a little bit. But let's go ahead and stop that there. Shoo! All right, enough clacky. Let me turn this back down here so you don't hear errant noises off of the piezo. But that is a pretty simple setup as far as wiring and code goes. You can do much, much more with it. You can trigger those from buttons, hit bells, all kinds of fun things you can do with that. Some questions from the chat. Let me switch back over to Discord here. The Sanjo asks, does anyone know if the max setting is a solid on, or would there be a little fluctuation, not 100%? I don't know. I mean, I think those are just opening up whatever the transistor is letting through, so there could be some variance there. I haven't put this on a scope or a meter. If anyone knows the answer to that, that's a good question. We may have info about the tolerances in the download page of the Learn Guide. Sammy Ohio, question made for solenoids and motors. You could drive some higher current LEDs. Don't see any reason why you couldn't. Sure, yeah. If you wanted to just Make sure you have the right resistance value on them, so you're not sending 5 volts to your LEDs. You could, I think, energize just electromagnets with it if you're picking up and dropping stuff. I've done that sort of thing before. Anything that just takes a high current blast of voltage should work well. Yeah, okay, let me see. There might be an answer C. Grover is typing, so maybe answer in there. C. Grover said it's a roof shingle nail gun simulator. I've seen some pretty cool larger solenoids, this size and bigger, that are 12 or 24, that people have used for shaking stuff on their desk to add to video games, so haptic feedback. I've seen a mouse with a huge solenoid on it. I've also seen some people who are doing like a tank or artillery gun simulator that involved huge like solenoids and butt kicker kind of bass drivers to shake stuff. Can a channel be PWM'd? I'm not sure. You know what? Let's take a look. Let's do a little journey over to, let's see if we can answer this on the driver page. So if we go to the Learn Guide on the CircuitPython and Python page at the top here, Liz put a link to the driver. So you can usually either go to examples and see if there's any anything outside of what was already in the Learn Guide. So here's using event detection for those B row buttons. Here's LEDs and buttons. So here's an example using buttons to trigger LEDs that are plugged in. And let's see, the direction output, that is on port A pins. Those are just being set to true, so that's just full bore. Simple test, we already checked that one out. So then you can look at the driver, and maybe the answer lies there. So if we head over to driver page for this particular one, there's no reference to PWM in here, so I'm gonna guess, looking at this, that no, it's an on or an off with this. Yeah, I think that's it. Yeah, open drain or push pull are your second bit options. Active high, active low first. There is a slew rate. That's interesting. On SDA. I think that's just referring to I2C. Yeah. So there's an interrupt you can use, but I don't think you can PWM these. These are just on or off. We probably have a different driver, multi-channel driver, that does the PWM better than this. There's a couple like we have like a 14 LED driver, I think, that'll PWM them all. Or constant current, even better. So anyway, that is what I have on that. So let's wrap this up. I'm going to hold that one up since it's a better, or I'll pretend to hold that up since it's a better picture. That should do it. Yeah. Okay. So that right there is the product pick of the week this week. It is the I2C 8-channel solenoid driver board with Stemma QT. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week. Don't forget, if you want to pick some up, head to that URL. 6318 is the product ID. And go get yourself some. All right, thanks everyone so much. For Adafruit Industries, I'm John Park. I will see you next time. Bye-bye.